Hello everyone, I welcome you all on Scientific Research Gurukul Classes. So today our topic is complex number. We will discuss few important topics of that complex number. So let's discuss. So what is that complex number basically means? It is the most important topics of class 11 maths, right? Everything like for exam or like any entrance exams and all. So what is the complex number? So actually the complex number is a number which we can express in the form of z. So z basically represent the complex numbers which can be equals to a plus iob, that is I is read as iota. So what is iota we will discuss later. So here we will first describe what is a, and here a and b are actually the numbers, those are real numbers, and that I is actually root over minus 1, that is a kind of imaginary number, and we read that I as iota. Okay, so here the real part of z, so that is a complex number. So here the real part of that z is given by re of z. Re means real of z, real part of z. So it can be a, so a will be the real part of z, and that b is embedded with iota, that is imaginary parts. So here the imaginary part of z is given by Im of z, that is b. So we can depict in this graph forms. So here if this x-axis or horizontal axis is real axis and that vertical is imaginary axis, then there is a angle theta which is equal to tan inverse b of a. We will discuss these things, what theta call and all. So here this line we can represent as a plus iota b, and here mod of z, that is modulus of z, we will discuss later. It is root over a square plus b square. So next, what is purely imaginary? As the name suggests, for being purely imaginary, what it means, it contains only the imaginary part. So what it means, we can say that the real part must be 0. So here the purely imaginary means the complex number is purely imaginary only if its real part of z is 0. So real part of z should be 0. So next is purely real. As the name suggests, for being purely real, imaginary part should be 0. So here the complex number is purely real if imaginary part of z equals to 0. Now it's important to know about iota, because iota is a thing, iota is a symbol, or iota is a value which was derived from some kind of history, and there is some mathematician related to it, great mathematician Euler. So basically the concept of imaginary numbers was first introduced by the mathematician Euler. You will read many formulas, important formulas of Euler in physics also, class 11 intro. So here he was the one who introduced that I is iota, I, that is iota, and it is represented as root over minus 1. He also defined not only I, he also defined what is the value of I square. He has defined another thing, that is I square, iota square is minus 1. Obviously I into I is what, minus root over minus 1 into root over minus 1 is going to be minus 1. So here we can say few important things. I equals to root over minus 1. So if we will calculate I square, what will happen? The square of this root over minus 1 square. So minus 1 root over square, root over minus 1 square is going to be none other than minus 1. So here we can say that iota square or square of iota is minus 1. That is very important. We have to understand this. We have to keep it in mind, not to remember or mug up, but we have to keep it in mind. So now further, what will happen? We will calculate I cube. So how we can calculate I cube? So here I cube can be written as I square into I. So we know the value of I square is minus 1, and minus 1 and I is I. So minus 1 into I is obviously minus I. So that is very important. The value of I cube is going to be minus I. Next, I4. So what we can write I4? I4 we can written as I square into I square. So that will be I square value minus 1, I square value minus 1. So minus 1 into minus 1. Obviously it is going to be plus 1. So I raised to the power 5 is going to be 1. So similarly, what if you will calculate I5? So it's okay now. I5 will be I ki power 4 into I. So I ki power 4 is 1. 1 into I is I. So we can write I ki power 5 is I. And similarly, I6 is similar to that I2 minus 1. And I7 is similar to that only I3, right? And all. It will go so and so on. So we have very important concept that we have to prove here is what is the value to prove that that is we have to prove that 1 plus iota I plus I square plus IQ is 0. That is very important but very easy. So taking a LHS, we will put 1 plus I square plus iota cube. So here 1 can be written as 1 as it is, I is as it is y, but I square can be written as minus 1 and I cube is written as minus I. So plus into minus is obviously minus, and plus into minus is minus iota. So plus 1 plus iota minus 1 minus iota. 1 will be cancelled out, 1 minus 1 will be cancelled out. Not next is iota minus iota will be considered as 0. So here 0 is equal to RHS. Here LHS equals to RHS. That is very, very important concept. That is 1 plus iota square plus iota cube is going to be 0. Now next, modulus of complex number. As the name suggests, modulus is the value, right? Modulus value, okay, magnitude. So it is the absolute value and represents the distance between the origin and the given point. So here we can calculate that the distance between the origin and the given point. If this point is like this point is P or something like that, which can be written A plus iota B. So here, so the length from this to this is that modulus, and that modulus value is this root over A square plus B square. Here we will calculate. So it is known as the magnitude of complex number. What? Modulus of complex number is also known as magnitude of complex number. And for any complex number z equal to A plus iota B, modulus z, that is mod of z, we can read root over A square plus B square. That is important but easy. So next is argument of that complex number. As I have already explained this, so it is basically the angle between the radius vector of a complex number and the positive x-axis is called the argument of complex number for any complex number z plus iota b. So that theta equals to tan inverse b by v, as I have already explained here. So this angle between that real axis and that a plus ib is theta, that is okay. So that theta is tan inverse b upon a. So this is the argument of complex number. Now what about different forms of complex numbers? So basically there are various forms of complex numbers, and that are, first is rectangular form, polar form, and third is exponential form. So rectangular form is very easy, traditional method. So rectangular form is also known as standard form, and it can be represented as a plus iota b. Taking an example, we can write here 5, a is a 5 and 5 iota. Another example, minus 3 minus 4 iota. Here minus 7i is also a rectangular form, because here the value of a is 0, so it can be 0 minus 7i. So 0 is also a real number, that's why it is also a complex number, and this complex number is in the rectangular form. It is important to note. Next, polar form. So for any complex number is represented as r of cos theta plus I sin theta. So here that value cos of pi by 2 plus iota sin pi by 2 is example of polar form. Next is 5. Here r is 5, and cos of pi by 6 plus iota sin pi by 6, etc. Next is exponential form. So basically the complex number is represented as r e of I theta. R e is exponential, I is iota, and theta is the angle, right? So here you can take the example e raised to the power I0, e raised to the power I pi by 2, 5 e raised to the power I pi by 6. Next. So next we have some formula related to complex numbers. So two formula we will write. First is Euler formula. The Euler formula can be written as e raised to the power iota x, that is e raised to the power ix is equal to cos of x plus I sin of x. That is important to know. If you will remember this formula, some topics of that complex number you also have to remember if you will get admitted into the BTech. So probably in the first semester you have to read in the maths. There is a maths you have to read in that engineering maths we call it, and we have to read in that BTech, right? We have also read that Euler formula in that BTech. So Euler formula is e raised to the power I of x, and which is equal to cos of x plus I sin of x. Next is de Moivre's formula. De Moivre's formula is also very easy, not a big deal. So here it's cos of x plus I sin of x whole raised to the power n. So what happens, this n is simply get multiplied with this angle x. So cos equals to cos of nx plus I sin of nx. We will read it once again. So that is cos of x plus I sin of x whole raised to the power n equals to cos of nx plus I sin of nx. Thank you for watching this video. If you like our video, so please subscribe, like and share. Have a great day.